Therefore, a function f from set x to set y, which are non-empty sets, such that every x or every member of set x is associated with unique member of set y. For each x, we get a definite or distinct y. Therefore, f is 1, 1. Also, conversely, for every y in set y, we get distinct x's in set x. Actually, at the last step, we have to express inverse in terms of x. Thus, we have got the inverse function of this given function f. Next, 1, 1 or injective function. As per definition, I take a set x and set y, which are non-null sets. Now, definition of injective function: if f be a function from set x to set y such that each member of x is associated with unique member of set y. Now, let us clarify the term unique. Actually, if we take x1, x2, two different members of x, and if we find their images are same or equal, that will be possible if x1 is equal to x2. That means no two pre-images will have the same image, which is calculated or explained by this also. Therefore, a function f from set x to set y, which are non-empty sets, such that every x or every member of set x is associated with unique member of set y. This is 1, 1 injective function. The example I have taken earlier, we find that images of 1, 2, 3 are different. That means different as well as pre-images are different. Therefore, every x of set x is associated with, I can express that by this diagram. One, two, three, 3, 4, 5 and 6. This function f is satisfying the condition of 1, 1 or injective function. Therefore, in this case, f is 1, 1 function. Now, the third one, for that I have and draw the diagram. Here I have taken two sets having members 1, 2, 3, 4, 3, 4, 5, 6 in y, and that is the function f is given by y is equal to fx Now we can calculate easily. F1 will be equal to 3, F2 4, F3 5, F4 6. For the pre-image 1, image is 3. For the pre-image 2, image is 4. For the pre-image 3, image is 5. And for the pre-image 4, image is 6. That means every member of set Y is associated to a member of set X. That means each member of Y is associated to some member of set X. In this case, we call the function f is onto function. Also called surjective. Thus, we have discussed a function will be into function 1 function or onto function. Next, we shall take few sums to clarify. I am going to start. Already I have written on the board. First of all, bijective function, invertibility, then few standard real functions, algebra of real functions, domain and range of functions. In the last episode, I discussed different types of functions. Detailed will be discussed in class 12 syllabus. Already I have discussed two types of functions. Number 1, 1 function. Number 2, onto function. Next comes bijective function. If a function f x, y, both are subset of set of reals. B 1 as well as onto. Then f is called bijective function. with the help of diagram, this is set x, this is set y, and the function is this. From the diagram, it is clear that members of set X, I have taken x1, x2, x3, x4 are connected to the members y1, y2, y3, y4 respectively, members of y. And what we find, each member of X is associated with distinct members of y. Also, number of elements of X and number of elements of y are same. Then for each X we get a definite or distinct y. Therefore, f is 1, 1. Also, conversely, for every y in set y, we get distinct x's in set x. Therefore, this function is 1, 1 and on 2. Hence, we call this function as bijective function. Now, one interesting thing, in case of bijective function, we can also define a function from set y to set x, as every y of set y is associated with a distinct x of set x. Then we can easily define a function, or we can find a rule which will associate every y in set y to a distinct x of set x, and that function is called inverse function. If we denote that by g, then g is the function from set y to set x. For the function f, inverse function, symbol of inverse function is f inverse, f to the power minus 1, that is hence in case of bijective function we can easily define inverse function which associates every y of set y to a distinct x of set x, where f is bijective function from set x to set y. Now, if it is asked to show the given function is bijective, then we have to move step by step. First of all, f is to be shown as one-on function. Then it is to be shown that f is onto function, then we conclude that f is bisective function. Also, it is asked that find first of all show the uh, invertibility of the given function and find the inverse. For that, the first step will be showing the given function as bijective function. Then we conclude that f is invertible. After that, we find the inverse function of the function f. Now I have taken an example to show this function fx is equal to 2x minus 5, where x is any real number, is bijective function. We have to follow these steps. For one function. Also, already you have learned other term is injective. Let x1, x2 be any real numbers. If x1 is equal to fx2, if fx1 equal to fx2, then 2x1 minus 5 is equal to 2x2 minus 5, or 2x1 equal to 2x2. From that we get x1 equal to x2. Thus, if the images be same, then their pre-images must be same. From this we conclude, therefore, f is one function. Now let for onto function. Now let y is equal to fx is equal to 2x minus 5. On transposing we get 2x equal to y plus 5, or x equal to y plus 5 by 2. We have expressed here x in terms of y. From this we find that for every real y we will get a real x. If we call this as 1, from 1 it is clear that for every y, of course real, we will have a distinct x, and that is the criteria for fx to be onto. Therefore, fx is onto function. From these two, f is one function, then fx is onto function. Therefore, f is a bijective function. In the first part, we have shown f is bijective function. Then according to the discussion, we can say therefore the function is the function f is invertible. We have x equal to y plus 5 by 2. Therefore, inverse function of f is f inverse x equal to x plus 5 by 2 for all real x. Actually, at the last step, we have to express inverse in terms of x. Thus, we have got the inverse function of this given function f. Now, detail of functions will be discussed in class 12 syllabus. Now, we move to some real valued function.